Welcome to the group exhibit Hydrogen Fuel Cells at the Hanover Fair and Batteries at the Hanover Fair 2017. I would welcome with me on stage Dr. John Lowe, head chemist of Ames, Goldsmith and Ceimig.
Ames, Goldsmith, yeah.
Goldsmith.
Ceimig.
Okay.
It's quite hard to pronounce.
The presentation will be about going from research into production. The problem of scale-up in material synthesis. So I'm very much looking forward to your presentation. If you have further questions, please save them up for later. Help yourself with some coffee or drinks.
Okay.
The stage is yours. Thank you.
Thank you very much. Okay. Thank you for inviting me here. I would like to talk about, as I said, problems of scale-up in material synthesis. And first of all, I will give you an introduction as to what Ceimig produces and what our role is in terms of catalysts and fuel cells. I will talk about range of scale and then go through the considerations that we have to have in terms of developing those products, and also finally some research and development thoughts if time allows. Ceimig is a company which is based in Dundee in Scotland, and we have 10 fume hoods, an 8,500 square facility, a class 100 clean room, and we are the sister plant of Ames Goldsmith, which is in the UK, and Ames Goldsmith UK is a division of Ames Goldsmith corporate. So just to give you an idea of where we are, where we're based logistically, we are based obviously in the UK here, and we have a couple of major plants, large industrial in the States and small industrial in Taiwan. So what are our interests? Well, Ceimig develops and supports a range of silver products for the Ames Goldsmith group. However, more akin to what we do in Ceimig itself is production of the platinum group metals, and that would be ruthenium, iridium, platinum, golds, and some osmium as well. We also do some research for the next generation of products as well. So what typical products do we make? Well, we make products for biosensors. That would be a ruthenium hexamine trichlorides complex. And we do gas sensor materials, which would be gold black and platinum black. And probably of interest today for a lot of people would be fuel cell and electrolyzer products, which would be iridium ruthenium, platinum with carbon support. But we also do catalytic materials, which would be high surface area platinum black. And we also do some secondary products, which include cell staining for TEM imaging, which would be osmium tetroxide. Okay. So what dictates scale? Obviously cost, customer demand, and the chemistry. So all these things combined will actually determine what scale we produce at. So within Ceimig, we will actually produce in the micro lab scale, which would be in the gram scales, and we would then take that to small lab, which is everybody knows from chemistry days in college or school, would be this sort of setup here. However, more often than not, we actually produce in the kilogram scale, which would be large round bottom flasks, which typically would hold about 20 litres. And we also do, or have the potential to do a large lab, which would be 50 litres, 100 litre scale, which would equate to 100 gram products. So 100 kilogram products. Okay. So also out with Ceimig, but in our sister plant, we can also do small industrial. So we're taking it from lab scale into this typical scale here, which would be 100 kilograms, and then also large industrial, which most people are familiar with seeing on the horizon. So change of scale is not a foregone conclusion. You can't simply just take a small amount and go, yeah, I'm going to make tons of that. It doesn't quite work like that. So I'm going to show you some of the problems. So one of the problems we have is we could typically, I think I've jumped a slide there. We can go from liquid to solid and solid. So if we want to go from liquid to solid, we can have things that are colloidal, and if I want to take that out, that's a problem for me. So suddenly I have this problem of taking it from a liquid to a powder. It's not a foregone conclusion. Also, some of our products, this is osmium tetroxide, it's beautiful crystal, but if I was to leave that overnight in air, suddenly it sublimes, and if I come in the next morning, look what's happened to my osmium's disappeared, and that's quite an expensive mistake. So, chemistry considerations, well, I could do this ad nauseum in terms of putting variables up here. Things like performance, stirring speeds, volume change. So there's a lot of things we have to think about when we go from a small scale to the much larger scale. Typically, as I said, shown in one of the previous slides there, colloids quite often remain as colloids. And that is a big problem. If I don't get any agglomeration happening, I can't retrieve my material. And if I can't retrieve my material, that is a wasted product. And if I do get it to agglomerate, suddenly my nanoparticles are now huge, big particles, and that's not particularly good for anybody. Centrifugation, we could do that, but that is unpracticable when you go to the higher scales. Additional steps. So if I was, for instance, to try and treat that colloidal solution, that would be more work, and it would be cost, and it would also more likely give me a yield reduction. Again, not so good. Cleaning by dilution, as we'll see in one of the slides coming up, that can give me problems as well because I end up with large waste. And factory temperature fluctuations, health and safety exposures, and yield. If I'm doing platinum group metals, yield is everything. I can't afford to have a 95% yield. If I was an organic chemist and I get 95% yield, I'd be ecstatic, but not when you're doing catalytic powders. So, customer considerations, are we cost competitive? Obviously. Do we satisfy demand? So if you come to us and ask us, can you make a kilogram of that? The answer is, well, yes, but you know, that's the sort of questions that you have to think on. So it's all right to make a few grams of it, but can you satisfy that demand to make kilograms of fast, or even into the tons? Are products acceptable in regards to possible contaminants? So what's a contaminant for you might not be a contaminant for somebody else. So the chemistry might have to change. Also, should we be working on next generation products? Again, that's something that customers will come to us and ask about. Okay, so practical considerations. I think I jumped a slide again there. So waste. So typically with our waste, we can't just simply throw it away. It's precious metals that's in there, it's platinums and such like, so we have to wash things out and we have to be very careful. We can't just suddenly get rid of it, which actually drives us to be environmentally friendly. Okay, we might get there. Yeah. Okay, there we go. Back. So recovery, this here is gold that we've recovered from waste products. So we would actually put that in the furnace and obviously try and maintain that. 1 gram of gold roughly equates to let's say about 100 euros. So, you know, we have to be very careful about what we put down the sink. Packaging. How do we package materials? It's another consideration. So, you know, each one of these we have to individually make. Obviously a time effort with that. And obligations. So if we have lots of liquid waste, what do we do with lots of liquid waste? Do we simply pour it down the drain? Not really. So how do we get this to a satisfied conclusion? How do we extract that out of there? Again, that's something else we have to think about when we go to a larger scale. If you've just got a small beaker, then you can just more than likely put that down the sink. But with this, no, we can't do that. Far too much waste. And when it goes wrong big time. Yeah. So again, that's another consideration. Okay. Let's see if this can move on. Okay, so yeah, so that's some of the considerations. Research and development, very quickly, just to push on with that. Typically, we have 3 types of research. It was actually a UK study, and from that, there was actually 3 types of research is found to happen, to occur. And typically, discovery research occurs at universities, and that would be not for profit, and that's like fundamental research. However, translational research and applied research is more where we are. So we would actually take something and we'd actually try and find out if we could actually put that into a product, and then could we actually then sell that, because at the end of the day, we don't exist if we don't make a profit. Universities will still exist if they don't make a profit, but we have to make a profit. And certainly in UK government and probably European governments, they realise this and they're actually trying to get this feedback now to get this relationship with business and universities. So I think I'll just jump on a slide here because we're running late on time. Just to summarise, the energy storage and generation sector is pushing catalytic products into mass production, and we are hopefully going to be there as part of that solution. Good research doesn't necessarily mean that you're going to get good production. Just because you made a few grams of something, it doesn't mean to say you can scale that up at all. Next generation materials does not equal next generation products. That comes through qualification as well. And the take-home message for today is upscaling. It's not a foregone conclusion. Don't make the assumption. Don't make the assumption that you can suddenly just make something in a university lab and hey presto, we're going to scale that out and make tons, kilograms, whatever. It's not going to happen. So finally, I'd like to thank basically Hanover Messe for hosting us here, University of St Andrews for research work, and my parent company, Ames Goldsmith, for allowing me to be here today. Thank you.
Thank you very much. Warm applause for Dr. John Lowe. Are there any questions for this topic? Not at the moment. Okay. I would like to refer to the booth. If you have later on some questions,
yes.
It's booth D75.
Yep, absolutely.
So pass by, see what they're doing, ask questions,
absolutely.
and enjoy. Thank you very much
Thank
for
you
your
very
time.
much. Thank you.
So the next presentation will start at 2 p.m. It will be held by Rix Industries, and it will be about driving down costs to unleash the expansion of vehicle fueling infrastructure. I'm very much looking forward to this presentation, and I hope you join us for this as well. Thank you very much.